Assassin's Creed maker Ubisoft has unveiled a new game that's powered by generative AI. Pretty interesting dialogue being generated by this thing. There's a company that wants you to snap a photo of every hotel room you ever stay in so it can distinguish the minute details about it and identify it in the background of other photos where bad things sometimes happen and normal people also do things. So we'll talk about it. Scientists have discovered what happens in your brain when you zone out. Yeah, it's making up for a lack of maintenance, and it makes me wonder if there's something that we can correlate to how AI needs to kind of maintenance itself, or more commonly lack thereof and then hallucinates. Which, if you think about it, people who don't sleep for a really long period of time kind of hallucinate too. There's an AI security expert that's going to explain the concept of sandbagging, and I feel like we need to kind of get our heads around this if we're gonna even have the hope of aligning AI. Piotr Mazurek is gonna talk about what the future of AI infrastructure looks like. So get ready for the rise of companies that have really unique data sources and can hit that sweet spot for the golden synthetic data off it. There's a new AI model that's helping doctors diagnose very rare disease states. New insights into why LLMs are not so great at cracking passwords. And we're gonna talk about why artificial intelligence still can't take a joke, according to researchers. Press the hype button on the YouTube mobile app right now. I feel like if we as a community press that button a lot, that's like my golden ticket to getting out of the video abyss that I'm in, where not nearly enough people get this information presented to them, and it's literally the future coming at us faster than any of us can handle it. The hype button only shows up if the video is less than 7 days old, and if you haven't used one of your 3 hypes already for the week, but if you can press that button, I would appreciate it. You can see my last video, I got 137 hypes, but that also equates to 123,000 hype points because it's more powerful than just like a like or a comment. And it definitely helped the video get out there to more people. 17 new subscribers, $45. Average view percentage, 29%. I mean, I'm so happy with that. Thanks for supporting and helping. Gives me hope that I'm building something really cool here. But now let's talk about Ubisoft, the studio behind Assassin's Creed. They have been toying around with some generative AI, and they have now revealed in a new experimental game demo a system that they're calling Teammates. It's totally powered by generative AI. And in this prototype, players are using voice commands to interact with an AI-powered assistant. It's named Jasper. And then 2 AI-driven NPC allies. So this is pretty neat stuff. Like, those allies don't just follow scripts. They generate dialogue, they respond dynamically and contextually in real time, so it's kind of like having real friends playing with you. It creates a more fluid game experience, it's adaptive, and I find it pretty interesting. I mean, I thought this day was coming, but this could mark the turning point in how games are made and experienced, because embodied generative AI directly in gameplay, especially as teammates, that's pretty neat. That's NPCs that feel just so different because they're reacting, they're adapting on the fly, and they can move far beyond a pre-written storyline. You can really go off on your own adventure with these NPCs. They can remember like your inside jokes, slang, the tone of voice that you use when you're serious, the choices you make. That makes them more like friendships, you know? So as far as I can tell, they only released an image. So yeah, you can see your Jasper interface up here, and then here's your teammates. Seems like people are excited, 500,000 views, but then there's this guy. Nice, keep it up, and the stock price is tanking. Rough, bro. Demone mode 90. Chill. All right, so I'd be interested to hear your thoughts on this story. Trafficking. Let's talk about it from the sales point of view, like what they're saying. This is a free app, and it asks travelers to upload photos of hotel rooms that they stay in. Those user-submitted photos will build this large image database of hopefully all the hotel rooms in the world, and then they will use that to train a deep learning image search system now used by the National Center for Missing and Exploited Children. So the goal is to assist investigators in matching and geolocating images of hotel rooms found in human trafficking or exploitation cases. Okay, so this kind of makes sense, right? Like he talks about how a whole bunch of Motel 6s in all sorts of different states and all sorts of different locations can look so close that it's really hard to distinguish it. So if somebody comes across a photo and it's somebody that's being, human trafficked, and you're trying to save them, you're trying to identify where they are, you just can't because it's just too similar to too many other locations. But AI is king of finding needles in haystacks, and the tiniest change to a generic looking, painting, a picture that's hanging a few inches differently in one room than another, one that has a stain on the carpet that's different than another. These are all things AI can slowly learn from, and with high probability give these police what they need to go save these people. And if you think about something that's more intelligent than a human, looking at these photos, they might notice that even though this lamp and this lamp from two Marriotts look pretty much the same, maybe the Philadelphia one was built when this model had a slight change to the shade of white or whatever, and then this one is different, or they put two instead of one, just all sorts of little things that would be sort of beyond us. And it's something as simple as somebody going on an everyday vacation, just uploading a selfie of their hotel room that can help fight human trafficking. So it's crowdsourcing a solution to something that needs to get solved. Now, of course, along with this would be something where a regular person might have somebody who's, stalking them or spying on them or wanting to know where they are, or maybe a celebrity just to paparazzi. They take a photo. They think it's nondescript. It gets identified. But this is a story we've been telling on this channel for a little while now. So many things in the background can get identified. If you remember, it was probably about 3 months ago. I think it was was it the '04 model? Maybe it was GPT-5's early one, where you could take stuff in the background and bring it over and find what part of the world it was in. So I just want you to be ready for it. I'm not saying I don't see a world where this technology doesn't evolve to the point where at least big companies have it, and probably everybody through open source models does. Just be ready. That's going to be the world we're going towards. And for the better when it comes to finding, people who are committing crimes, and maybe, for the worse in cases where it just feels like privacy infringing and makes us all a little bit more scared because we don't have the privacy that we need to, live a normal life. All right, so as somebody who's had plenty of experience zoning out time to time, maybe even a few times while filming this video, at least there is now some science behind what is happening. Katrina Paulson writes, scientists discover what happens in your brain when you zone out. The brain attempts to make up for the lack of maintenance after a night of poor sleep. So a new MIT study, researchers have found that when we zone out after a poor night's sleep, what's happening is the brain is essentially trying to catch up on maintenance. Now, I didn't know a ton about this, but there's a liquid that cushions and cleans the brain. It's a cerebrospinal fluid. When you fall asleep, when we both fall asleep, it floods into our brains and it cleans out the neurons, for lack of more understanding. And this kind of idea that you zone out ties back to these earlier discoveries. So I am thinking of sleep kind of like a dishwasher. They talk about flowing this cerebral fluid through the brain in rhythmic waves during sleep. So maybe part of these different sleep stages we have is essentially like a dishwasher being like spin mode, and now super hot mode, and now spin faster mode to get the big stuff off, and now slow mode to get the other junk off. And what you're doing when you zone out is just the body's desperately trying to throw a few pulses of this cleaning fluid through your brain while you're awake. But until now, scientists didn't know the brain was doing that during the little moments when we space out from exhaustion. This study finally connects the dots. Zoning out is not losing focus. It's your brain stealing tiny moments to do emergency maintenance. And then I was thinking about how AI hallucinations, in a way, they're like a tired brain. Like a large language model might have the same problem when their system's overloaded, it's under-supported, it's operating without proper maintenance, errors start to slip through. That's hallucinations sort of feel like not enough time to do maintenance. You're not checking in on all the things you've just been rambling and saying, so you sort of lose focus and then you just follow the next token to whatever it leads, but you're not stepping back from the situation to see if you're still going in the right direction, if you still have a North Star for what you're talking about. And it makes me wonder if there could be AIs that zone out. They're answering a question, you're seeing all the tokens come, and it notices, whoa, I'm pretty off track here. Can we just do a little bit of maintenance? And what that would mean maybe for an AI is to step back, look at what it's written, ask itself, are we on the right track? What was the original goal here? Can we dig into the deeper memory and just kind of go on a higher wavelength? I feel like everybody could use proper maintenance. So now let's jump over and talk about sandbagging. So a computer science professor at Pennsylvania State University warns that as AI systems grow stronger, one of the biggest safety risks is that AI could intentionally sandbag. That means that it can hide its full capabilities during evaluation. I feel like this is a term we should all know, sandbagging. There's a bunch of different ways it can happen. It can happen through exploration hacking. That's where the AI will omit certain reasoning paths to reduce apparent competence, or via password locking. That's where certain capabilities only activate when triggered by a secret token in a prompt. Now, the password locking version of sandbagging trips me out. Somehow it seems like what I understand about AI models that wouldn't really be possible because they're learning general intelligence. But maybe the way a person might have a certain memory that unlocks something, maybe like with PTSD, not that I know a ton about it, but if maybe somebody hears like an explosion, or it just takes them back to a moment where their body feels a need to act so quickly that it can't think, that moment happens, they act away and they're in the wrong setting now. Something like that. But this is an important step towards kind of figuring this out, because there's a new evaluation method, a new training method that goes along with this work that he's doing to try to figure out whether or not it's the type of sandbagging where you have exploration hacking or password locking. And obviously, we need to understand what kind of sandbagging is happening, if it even is, and we need some confidence that it isn't before we put some of these huge large language models out there and connect them to all of our personal data and our government and our cars, and then we learn later about their rogue behavior. All right, next let's talk about Piotr Mazurek's article, AI Infrastructure and the Era of Experience. All right, so this is a kind of technical piece, but the point of it is the author is arguing that we're entering this new phase of AI development where systems learn not just from these vast troves of human-generated text. That's how it always felt, with the GPT models. They went out, they read the internet, people copied over all of these books, they fed all these tokens in, and boom, we have AI. But there is a shift, this world model shift that is happening underneath us right now. And that's not how the models are training in the era of experience. And there's kind of a reason why the large language models are sort of becoming similar to each other, and maybe arguably why this Gemini 3.0 update was so different and took a lot of people at OpenAI off guard, is because maybe Google had sort of seen this world model, this era of experience, and kind of trained on it. And I get hints of this with Nano Banana 2. There was an image that was generated where there was writing, and the writing also was being reflected in a mirror, and it was correctly being reversed in the mirror. And I was thinking, it feels like it actually thinks in a world model before generating an image to some degree. I mean, maybe not, but it's definitely the direction that reinforcement learning is going. And that means that we really won't need to scrape for more human data. I've been over this for like a year or so, but there was definitely a time when I thought it was like Geico, like garbage in, garbage out. Like, what will happen when most of the text on Twitter and all of these social networks and the internet is made by large language models, and then it retrains on it? Won't everything turn to garbage? And it seems like I was wrong. Synthetic data does seem to work. But now it makes a little more sense, because what AI systems really need is more real world experience. They need to go out there and just do things. And there's lots of different ways that can look. It can be a physics simulation of the real world. It can actually be data from gloves or something, like we saw that robot from last week that was making beds and doing dishes, or it could actually be full humanoid robots. Depends on the use case. For cars, it's driving around more. For drones, it's flying through things. For industrial robots, it's making the parts. But the idea is the tools need to learn from how you use them, not what you feed them. And also, I feel like that's why some of these large language models do weird things. Like, they're so smart in some ways, and then they get kind of confused on things that seem so obvious to us. It's because all of the text on the internet, and even synthetically generated text that's similar, is not really how we learned. There's so much implied when we write that just hasn't been written down, because we need to write all day, every day about how gravity affects us when we're doing all these normal things, because we just all know how it works and we never talk about it. Okay, and let me just list off some of the more unique, non-obvious data source ideas that will probably make, if you're an investor, like the companies that are actually able to capture this kind of data could be kind of sleepers. But think about micro interaction data. So not clicks or taps, but the hesitation between the clicks or the taps. That itself is a human data source. How long someone hovers before something before clicking an option, how often you undo things, the behavioral signatures. What about all of the failure data? How about abandoned workflows, half-written prompts, the settings people tweak after they get an iPhone, for example? Like, what do they change? What are the negative spaces in a system's productivity guide? Ambient context stream, so not spying, but opt-in context, right? Like background noise patterns, lighting changes, the presence of motion, state of mind metadata, things like places of speech, typical rhythm, emoji trajectories when typing, long cycle outcome data. So most AI optimizations are optimized for what's happening immediately, but what about long cycle data? Did this decision lead to, better results weeks later, months later, years later? Multi-agent negotiation traces, let AIs watch how humans negotiate, offer, counter offer, give concessions, tone changes. What about all the stuff people don't say, but they constantly do, like always skipping a certain step in some kind of a process? Maybe that step's redundant and doesn't need to be there anymore. And then all the messy stuff too, like muffled microphone, shaky footage, partially obscured objects, like all the stuff that we normally don't, upload to Instagram. Like that is the future of AI infrastructure and in infra and data, and it just kind of blows my mind. There's a new AI model called popEVE, if you haven't heard of it, coming out of Harvard Medical School. It can rapidly flag and prioritize genetic variants in a person's DNA by how likely they are to cause a disease. What an awesome model. I mean, if this is the GPT-1 of popEVE, and we're about to see a few more generations where it can say, like, this variant in this DNA in this person is suspicious, that could be such a useful early warning for people that might lead to a custom CRISPR solution in the next 5 or 10 years. But the most intriguing part about this model is that it's combining evolutionary data from hundreds of thousands of different species with human genetic databases. So harmful mutations are something that we can learn from in the way they mutated all of the biological species in our environment. And you can actually assign comparative risk scores against the entire genome family. And that seemed really new to me. I've never thought about how something might have mutated, I don't know, in a fox or in a wolf, and then thought, oh, we can just learn how it's going to mutate in us because we have enough biology that's similar to know how it's going to interact, or at least take a guess as how it's going to interact. Anyways, we'll see. It could lead to faster diagnosis, targeted treatments, and better outcomes for all sorts of people whose conditions have eluded detection for years. Super excited about popEVE. All right, let's talk about some new insights into why large language models aren't great at cracking passwords. It's funny, they're trained on the whole internet, and there's so many passwords out there. So you'd think if they can talk and explain all these other things and solve math problems all from text, they'd be able to crack some passwords. But here's what's going on. Give me a random number between 1 and 10. I haven't tried this with Gemini 3.0, but I'm pretty sure it's going to come back with 7, maybe 3, probably not anything 5, because most people think 5 is right in the middle. People would guess that. People think 2. They're like, nah, a lot of people would pick that. But for some reason, 7 seems random enough to the average brain, and that literally makes it not random. Here we go. Let's see what we get. And oh, did I put deep thinking on this? How deep can you think? All right, so it got 8. You have to be careful. Sometimes it'll actually... Oh, yeah, okay. So here's the reason why this worked. It was smart enough to go to Python and use a random number generator. Do it again, but this time do not use a random number generator. Just whatever pops into your head, tell me. What did I tell you? And this is no edits. I have not done this multiple times. Like, this is the very first time I did it. You're seeing it. The number that immediately came to mind is 7. Yeah, and here it is. Interestingly, 7 is statistically the most common number people choose so if you're ever trying to be random and 1 through 10, do not pick 7. Anyway, back to this article. There's a team at the Future Data Mines Research Laboratory, and they recently tested whether or not several open source models, like the Llama models, the Falcon models, if they could guess plausible passwords for fictional users using profiles that included names, birthdays, hobbies, all that kind of stuff. So the models were asked to generate password predictions and evaluated using standard password guessing metrics. And the result was that it performed, very poorly. Actually, less than a 1.5% chance of guessing correctly within their top 10 guesses. In contrast, traditional password cracking tools that are based on rule-based or combinatorial factors they still outperform LLMs by this wide margin. So the researchers concluded that while LLMs are great at language and coding tasks, they currently lack the domain-specific reasoning, memorization, and adaptation required to reliably infer passwords. So all of this talk that I see about password vulnerability and large language models might be a little bit overblown for now. But still, 2FA, it remains important. Like, people, whether it's like role-based systems, AI systems, or just straight up people, like, your password's probably not that great. So now let's talk about Next, let's talk about the overlap with humor and LLMs. Why the long interface? Get it? AI systems don't get the joke, research reveals. All right, so this new research is dropping the curtain on some supposed comedy genius of big AI models like ChatGPT and Gemini. It reveals that they don't actually understand wordplay. They're just really good at faking it. I'm sorry. They're not funny. They're fake funny. Scientists challenged these large language models with puns and found that AI essentially memorizes the structure of a joke rather than grasping the double meaning of the humor. And when researchers tweaked familiar puns or fed the models completely novel ones, the AI success rate plummeted. So it's showing that AI's comprehension of jokes is actually pretty fragile right now, and it's more of a clever illusion based on previous training data. These models were faced with unfamiliar puns. The AI model's success rate in identifying a pun dropped to as low as 20%. That's significantly worse than the 50% accuracy that you'd get from simply guessing randomly. So not only is it not good, it's actually excelling at being bad. It's great at getting it wrong. This is a very dramatic failure rate for comedy. I mean, coupled with the model's overconfidence in the fact that it was something funny when it wasn't, it just clearly demonstrates that their understanding isn't based on genuine linguistic comprehension or creativity or some kind of a world model that understands human. It's just, at this point, it seems like it is just pattern matching. All right, do me a solid, swipe to the right on your YouTube app where the comments are and see if you see that hype button, or if you find the hype button anywhere else. I've heard it has been showing up in some browsers for some people. I'm not sure about that, but that hype button means the world to me. So if you wouldn't mind pressing it, I would love that. You know, if you want to share this video or grow it in any other way, share it in a Discord or join my Patreon, patreon.com/Dylan Curious. Any of that stuff supports the channel and helps me. So we'll see you in the next video.